Hello everyone and welcome back to another video on binomial expansion. So in the last video we went ahead and solved x plus y to the power of 6, but in today's video we'll be solving x minus y to the power of 5. So not only is the exponent different, but also the fact that we're going to be subtracting y instead of adding y. So when looking at this problem, the first thing we're going to go ahead and do is refer back to Pascal's triangle, which again I have gone ahead and drawn out on the left-hand side. So reviewing back from the last video, we went ahead and found out that this top one coincides with x plus b to the power of 0. This next line is for x plus b to the power of 1. And it keeps going on. So this is to the power of 2, 3, 4, and 5. And because we have the exponent of 5 here, and we know that it's x plus b to the power of 5, we're going to go ahead and use these numbers, which is 5, 10, 10, 5, and 1. So knowing that, we're going to go ahead and write out 1, 2, 3, 4, 5, 6 lines. 1, 2, 3, 4, 5, 5, 6 lines, like so. And we're going to go ahead and use these numbers and plug them and put them on each line. So we're going to go 1, 5, 10, 10, 5, and 1. And so this is how we see the benefits of using Pascal's triangle when the exponent is low, such as 5. Because if we have a very high exponent, Pascal's triangle will just get too big because it keeps expanding outwards from the left and the right, and it'll just eventually go off the page like so. So now that we have our numbers written down, we can go ahead and look at our first term, which is going to be x. So like the previous video, we're going to give an x to each line, like so. And we know again that for the first term, we're going to start from 5 and we're going to go all the way down to 0. So we're going to go 5, 4, x to the third, x to the second, x to the first, and x to the 0. And we know that anything raised to the power of 0 is just 1. So we can go ahead and scratch that out. And so the next thing we're going to look at is going to be the second term. And before we go ahead and look at this subtraction sign, we're just going to merely look at y by itself. So we're going to give y to each line. And unlike the first term, we're going to start at 0 and work our way up to the power of 5. So 0, x to the first, second, third, fourth, and fifth. And similar to the x to the 0 down here, we have an x to a 0 over here, and we know again that anything raised to the power of 0 is merely 1. So we can go ahead and scratch that out. And so now we're going to go ahead and write down all our terms that we have. So we have x to the fifth, and leave a space in between so that I can show you guys how the subtraction sign plays out. So we have x to the fifth, 5x to the fourth, y. We have 10x to the third, y squared, 10x squared, y to the third. We have 5x, y to the fourth, and finally we have just y to the fifth. And so now when we had our other equation that we solved in the last video, which was x plus y to the sixth, we had an addition sign in the middle, so we can just add an addition sign between every term. However, because we have a subtraction sign, this plays out a little differently. So we're going to go ahead and look at each of the y terms, and that's going to help us decide where there's going to be an addition sign and where there's going to be a subtraction sign. So let's say we're comparing this one right here, y to the first. We know that technically it's going to be negative y to the first power, and that's just going to go ahead and give us a negative y. So there's going to be a negative in between there. However, let's say we look at y squared, it's going to be negative y squared, which is the same thing as negative y times negative y. And we know that two negatives make a positive, so that's how we get a positive y squared. And we can go ahead and do the same thing for y to the third, y to the fourth, and y to the fifth. So that's going to be a positive, that's going to be a negative, that's going to be a positive, and that's going to be a negative. So in other words, when looking at something that has a subtraction sign versus an addition sign, as we saw in the previous video, Another way to think about it, instead of just looking at what power the negative term is raised to and going from there, I've seen when we did up here. Another way you can think about it is when the negative term is raised to an odd power, it's going to be subtracted, versus if it's raised to an even power, it's going to be added. Like, for example, right here, it's y to the first. And because 1 is an odd number, we're going to do a subtraction sign. But whereas over here, we have y squared, and y is being raised to the second power, which is an even number, we're going to go ahead and add that verse instead of subtract it. And that is how you solve a binomial expansion, being x minus y to the power of 5.